Lesson 2, linear functions. So linear functions can either have a positive slope, a negative slope, or it could be constant. So we're going to graph y equals 5 and y equals negative 2. So y equals 5 would be a straight line going through 5. So this is a constant line. Negative 2 would look like this. So this is y equals 5, this is y equals negative 2. So those are constant functions. Okay, graphing a line, we want to first find our y-intercept. So y-intercepts are easy, it's your last number. So for this one, our intercept is +3, so we're going to plot that point first. Next, you're going to plot your points based on your rise and your run. So your slope is always the number in front of x, and if there's no number in it, underneath it, it's the same as 1. So for this one, the rise and the run would be 2 over 1, or we could make them both negative. Negative 2 over negative 1 would also make a positive slope. So from this point, we're going to go up 2 over 1. We could also go down 2, left 1. Down 2, left 1. You need to make at least 3 points, and then you can use a straight edge to connect them. And I can't use a straight edge on the iPad, so I will do my best. So that would be how you graph the first line. For the second line, we start with our y-intercept of 5, and our rise and our run would be negative 4 over 1, or you could say positive 4 over negative 1. When you have a negative slope, you need to make sure that only one of them is positive and only one of them is negative. So from here, we're going to count down 4, so 1, 2, 3, 4 over 1. Down 4 over 1. And using your straight edge, line them up. I'm trying really hard to use a straight edge right now. I'm sure you can make it look better. So for the next one, our y-intercept is at negative 2, so we plot a point at negative 2. Our rise and our run would be 2 over 3, or they could both be negative. So we're going to go up 2 over 3, up 2 over 3. You could go down 2, left 3 as well. Down 2, left 3. And then using your straight edge, connect the points. For the last one, it's not in standard form. So to put it in standard form, we're going to move everything that's not the y to the other side. This is a plus. So we're going to minus 2x from both sides, and we're going to add 6 to both sides. So we're left with 4y is equal to negative 2x plus 6. And we need to get y by itself, so we divide by 4. So we're left with y is equal to negative 1/2 x plus 1.5. So we're going to graph the 1.5 here, and then we're going to go down 1 over 2. So down 1 over 2, make sure you stay on the half point of the line. So it should look like this. You can also go up 1 over 2. Up 1 over 2. So our rise and our run for this one were negative 1 over 2, or positive 1 and negative 2. And using a straight edge, connect your lines. So that is how you graph linear functions. For the next example, we want to find the x and the y-intercept. So first, to find the x-intercept, we make y 0. So we have 0 is equal to 2x plus 3. Minus 3 from both sides. We get minus 3 is equal to 2x. Divide by 2, and we're left with negative 3 over 2 is equal to x. So that is our x-intercept. And our y-intercept is easy because it's just your last number. So y is equal to 3. For the next one, we have 0 is equal to negative 4x plus 5. Minus 5 from both sides. So we have minus 5 is equal to negative 4x. Divide by negative 4, and we're left with 5 over 4 is equal to x. Our y is our last term, so it's 5. For the next one, we have 0 is equal to 2 over 3x minus 2. We're going to add 2 to both sides, so we're left with 2 is equal to 2 over 3x. Now to get x by itself, we have to first times by 3 on both sides. This cancels this, so we're left with 6 is equal to 2x. Then we divide by 2, so 3 is equal to x. And our y-intercept is our last term, so y is equal to -2. And for our last one, for our x-intercept, we make y 0, so 2x plus 4 times 0 minus 6 equals 0. So we have 2x minus 6 equals 0. Add 6 to both sides, so 2x is equal to 6. Divide by 2, and x is 3. For our y-intercept, we make x equal to 0, so 2 times 0 plus 4y minus 6 equals 0. So we have 4y minus 6 is 0. Add 6 to both sides, so 4y is equal to 6. Divide by 4, and y is equal to 1.5. So example 4 asks, what does the leading coefficient do for our function? So if we have a positive leading coefficient, we know our line goes like this. So our end behavior will be from quadrant 3 to quadrant 1. If it's a negative leading coefficient, we know our line will look like this. So our quadrants go from quadrant 2 to quadrant 4. And this is for every single line. So the following is information to help you with determining information from graphs of a linear function. So know that this line right here has a positive leading coefficient, and this line right here has a negative leading coefficient. This line has a negative leading coefficient, and this line has a positive leading coefficient. So all of this information can help you answer questions for this section of the textbook and your assignments. Okay, for the following graphs, we're going to determine information from them. So for the first one, our degree is equal to 1. That means our shape is a line. The number of x-intercepts is 1. You can only ever have one x-intercept. And our x-intercept will be when y is equal to 0, so negative 0.25x plus 3. We're going to subtract 3 from both sides. And then we're going to divide by negative 0.25. So 12 is equal to our x-intercept. Our y-intercept is equal to 3. We know that from here. Our leading coefficient is equal to negative 0.25. So because it's a negative, our end behavior goes down like this. So it goes from quadrant 2 to quadrant 4. The domain for a line is always x such that x is an element of the real numbers. And the range for a line is always y such that y is an element of the real numbers. For the next one, our degree is 1. The shape is a line. We have one x-intercept. And the way that we find it is 0 is equal to 2x plus 3. We minus 3 from both sides. And then divide by 2. So negative 3 over 2 is equal to x. Our y-intercept is plus 3. Our leading coefficient is 2. That means it's a positive line. So our end behavior goes from quadrant 3 to quadrant 1. Domain is always x such that x is an element of the real numbers. And range is always y such that y is an element of the real numbers. So that is all the information for. Okay, writing an equation for a line isn't very hard. You have to determine the y-intercept and the slope. So for the first one, our y-intercept is 2. So that's our b value. Now we have to find our slope. So the way that we find that is we take y2 minus y1 over x2 minus x1. So we need to pick 2 points on the line. So I'm going to pick this point right here, which is at 2 and 3, and this point right here, which is at 0 and 2. So our point 1 is 0 and 2, and our point 2 is 2 and 3. So we're going to plug these in as x1, y1, and x2, y2. So we take 3 minus 2 over 2 minus 0. And it doesn't matter which order you do it in, as long as if you do this one first here, this number also has to be from the same point. So we have 3 minus 2 is 1, and 2 minus 0 is 2. So our slope is 1/2. So when we put it into y equals mx plus b, this equation is y equals 1 over 2 x plus the y-intercept, which is 2. So there's an equation for that line. For this one, our y-intercept is b, which is at 0.5 negative. Now we're going to choose 2 points, so I'm going to choose this point right here at -1 and 2, and this point right here at +1 and -3. So point 1 is equal to -1 and 2, and point 2 is equal to 1 and -3. So to find our slope, we do y2 minus y1 over x2 minus x1. Our y2 is -3, our y1 is -2, our x2 is 1, and our x1 is -1. So we have to minus a minus. So -3 minus 2 is equal to -5. 1 minus -1 is +2. So our slope is -5 over 2. So we have y is equal to -5 over 2x minus 0.5. So there's the equation for that line.